Hi 8th grade. The lab that you're going to complete today in class is called the Speed Lab. This lab is where you will be measuring the speed of a rolling ball as well as your partner typing. So let's go through the background and kind of how we're going to do this lab so that we make sure that you're good to go. So in the background it says, now that you understand the formula for speed, that formula being S equals D over T, it's time to put it to use. So just to recap, S equals D over T is the distance achieved in a period of time. So for the ball rolling, it would be how far it rolls in however long it rolls for, or however long you determine is the amount of time. For someone typing, it would be a little bit different because obviously you're not traveling an actual distance. So think back to 6th grade maybe when you were in that typing program. How did you determine your speed of typing, right? What was the thing that you were measuring in a certain amount of time? We're going to continue here. Speed in physics is usually used to describe the motion of an object from a fixed reference point. However, speed is also used to measure other things as well, like typing. This activity gives you the opportunity to measure several different situations involving speed. So the purpose of this lab, obviously, is to practice measuring speed. But more importantly, and the real purpose that we've got going on here, is to develop your method writing skills, which we're going to talk about more in detail in a few minutes. But one key thing to keep in mind is this lab is not about seeing how fast you can roll a ball or how quickly you can type. The actual numbers, how fast the ball went or how fast or slow you typed, doesn't matter. So if you mess up in your typing and you type really slowly today, or you're just not a great typer, the whole purpose of this is not to see if you're fast or slow. It's to get some data that we can use in a data table and a graph, but more importantly, it's for you to then think about the method that you used and write that method up in a way that somebody else could follow. We'll get into that in even more detail in a second. So you're going to work in your lab group, which will be pairs. You can pick your lab partner, but choose wisely. If you pick a lab partner that is not a good partner for you, meaning that your partner is not helping you get this lab done in a efficient manner, that will of course affect the amount of time that you have to work on the write-up and will affect your lab behavior grade. So pick wisely. You will then measure the speed of a ball rolling on the floor. So set out around the room, there should be a bin with different balls in there. You can pick whichever one you want to use. There should be some meter sticks, and then also a speed of a student typing. You or your partner can do this, and you can obviously just choose which computer you use to measure that. So let's go through this method here. And this is kind of my method for how you will do the lab. And it doesn't have a lot of details because I'm letting you pick how you actually find the speed of a rolling ball. So for step 1, it says, let's say that we're working right now on the rolling ball speed. Decide on the method of measurement. So essentially, figure out how you're going to determine how quickly that softball rolls in the classroom. Decide on the appropriate units. Remember, we always use metric units. That's a horrible T there. And write down the formula for speed. Obviously, we already know what that is, S equals D over T, but the reason that step 3 is in here is just to remind you to be paying attention to this. Create a data table, right? You're going to want some kind of data table so that you can actually be tracking how far the ball rolls and how long it takes the ball to do that. You're going to measure the speed 3 times. So trial 1, trial 2, trial 3, right? And then you're going to need another box down here because you're going to average your results. Use the formula to calculate the speed of the rolling ball and type up a short method section. This will be homework, number 8. Eventually you will also graph your speed based on this data. You will then repeat all of these steps for the speed of a student typing. So you're going to do this 2 times, right? You're going to do this once for finding the speed of a rolling ball and another time for finding the speed of somebody typing. What I suggest doing is that you take notes. while you do the lab. Because if you're taking notes, you're going to jot down information on how you did the lab. Well, we let the ball roll for this distance and we timed how long it took, you're going to jot down all that information, which will help you later over the weekend write up your methodology. So keep in mind the whole time that this is not about seeing who can, roll the ball fastest across the classroom and see who can smash it into the wall, right? That's not the purpose here, and actually that's not going to be helpful when you're trying to create a method. So a little bit about methods, and we'll come back to this in a minute. A little bit about methods. Before you run your experiment, before you actually start taking data, when you are working with your partner to create your method, there are a few things that you should remember. Methods must be performed so that anyone can redo your experiment exactly the same way you did. Not close to, not similar to, but exactly the same way you did, right? So you need to have wording in your method that explains exactly what you did. Methods should be written in a clear and concise manner. A sixth grader should be able to redo your experiment, right? Pretend like you're writing this method for a sixth grade student who has not had me as a teacher, who has not had any of the physics learning or reading that we've done, and is a little kid, right? You want to write this method so clearly that they can repeat it exactly the same way you did. Your method should contain all of the necessary details. Again, hoping that they can redo it exactly the same way. And methods can be numbered or written in paragraph form. Usually for this, it's a little bit easier to do it in a numbered fashion. Step 1, do this. Step 2, do this. Step 3. Because that way you're making sure that you're kind of breaking your ideas down into short, concise, manageable points of information. So once you actually have you're going to work with your partner and come up with how you're going to measure the speed of a rolling ball. You're going to take some notes, you're going to set up your data table, and then you're going to go and actually roll the ball, collect some data. You'll do the same thing for the speed of a student typing. Then what's for homework is this piece here. This is what will be turned in eventually via OneNote, but we'll get to that later. So the first thing is a data table and graph for the speed of the rolling ball. You'll also turn in a data table and graph for the typing information. You will then write up a method for how to calculate the speed of a rolling ball, and you'll type up a method for how to figure out the speed of somebody typing. So you're going to turn in essentially kind of 6 things here. You'll turn in, if we're thinking about this in terms of the rolling ball experiment and the typing experiment, you're going to come up with a data table for both, a graph of that data, as well as a method, right? You'll do that over here, and over here. So you're going to kind of turn in 6 different pieces to this lab, which is how it will then be graded. So these 6 things, the 2 data tables, the 2 graphs, and the 2 sets of methods will end up in one Word document. That Word document will later be uploaded to OneNote, but for now, don't worry about that piece. We can go over that in class a little bit more specifically later. So to recap what you'll be doing in the double period today, once you're done watching this video. First thing is pick a partner, and pick a good partner that you'll be able to work well with. The second thing is brainstorm and test out how you'll determine the speed of a rolling ball and of a student typing. So it's okay to kind of brainstorm and think this out and test some different methods out before you decide on which one you'll use. Third, do each experiment, meaning the rolling ball and the student typing, to get 3 trials of data from each one. Right? Try 1, 2, 3 of rolling ball and 1, 2, 3 of student typing. And you need to record that information in a data table. So that's not going to take you the whole class. All told, this will probably take you somewhere between 30 and 40 minutes, I would guess. So the remaining time in class, and anything that you don't finish up in class is therefore homework, is creating the 2 data tables on the computer, creating the 2 graphs on the computer, and writing up your step-by-step methods so that somebody else, a 6th grader, could redo this experiment. All 3 of these things right here should be done on the computer, right? Your data tables and graphs and methods, and they should be done individually. You're not writing these steps out with your lab partner. Your methods and your partner's methods should essentially be the same steps, but they're going to be written in your own words, right? You obviously both did the same experiment, but you're each going to explain it using your own words and your own way of talking, or writing in this case. So they should be done individually. If you don't remember how to make graphs or how to make data tables, you should refer to the How to Graph videos that are on my YouTube. You're already watching this video on my YouTube, so just go to the list of videos that I have. There's a whole playlist about graphing, so there's line graphs and bar graphs. One quick word on which one to pick. A line graph usually tracks something. It tracks change over time. And a bar graph tracks distinct or different quantities, usually related to trials. So I will let you decide whether or not you should use a line graph or a bar graph for this lab. This will all be done for homework or in the remaining time in class. Please send me an email if you've got questions on the assignment or anything like that, and refer to Schoology for the due dates of all the different parts. Thank you.